Hello, this is my 21st day of session 2 lecture, and we shall discuss today about some numericals based on the cylindrical and spherical capacitor, and for the purpose I have selected the two numericals based on the spherical and cylindrical capacitors. The first of all, I have selected the two numericals. The first one is a spherical capacitor has an inner sphere of radius 12 centimeter and outer sphere of radius 13 centimeter. The outer sphere is earthed and the inner sphere is given a charge of 2.5 microcoulomb. The space between the concentric spheres is filled with a liquid of dielectric constant 32. First, determine the capacitance of the capacitor. The second, when is the potential of the inner sphere? What is the potential of the inner sphere? What is the potential of the inner sphere? Compare the capacitance of this capacitor with that of an isolated sphere of radius 12 centimeter. Why is the latter much smaller? This is the first numerical which I have selected to understand the fact based on the spherical capacitor. For the purpose, now we shall discuss the solution of first numerical, and here are given the RA is equal to 12 centimeter and RB is equal to 13 centimeter. Now we convert them into the meter, means 0.12 meter, and this will be 0.13 meter. And the charge given to us, Q is equal to 2.5 microcoulomb, and the dielectric constant K, which is filled between the space of spheres, is 32. So these are the values given in the numerical, and now we shall determine the first part, that is determine the capacitance of the capacitor. We know that the definition formula for the capacitance of capacitor is 4 pi epsilon naught K RA RB upon RB minus RA. 4 pi epsilon naught K. K is dielectric constant. K is dielectric constant. Now we shall put the values of this capacitance . The capacitance is equal to, the value of K is 32, RA 0.12 multiplied RB 0.13 upon 1 upon 4 pi epsilon naught is 9 into 10 raised to the power 9, RB minus RA 0.13 minus 0.12. These are the values which I have put in the formula. Instead of 1 upon 4 pi epsilon naught, we have put 9 into 10 raised to the power 9. This is 32. This is the value of RA and RB, and this is the value of RB minus RA. Now, we solve this. C is equal to 32 into 0.0156 upon 9 into 10 raised to the power 9 into 0.01. This is the value which I have obtained. And now on solving the capacitance of the capacitor, the value will be is equal to 5.5 into 10 raised to the power minus 9 farad. This is the value and this is the answer of first question. 5.5 into 10 raised to the power minus 9. Now we shall determine that it was the first part, and now we shall discuss about the second part of the numerical, and that is B. What is the potential of the inner sphere? So we know that V is equal to Q by C. The value of Q is, we know that the charge is given to us 2.5 microcoulomb upon the value of capacitance 5.5 into 10 raised to the power minus 9, or V is equal to 2.5 into 10 raised to the power minus 6 coulomb upon 5.5 into 10 raised to the power minus 9 farad. So the value of potential will be obtained near about 4.5 into 10 raised to the power 2 volt. This is the potential of between the spheres or inner sphere, and this is the capacitance. Now we shall discuss about the third part of the capacitor, third part of the question, and that is compare the capacitance of this capacitor with that of an isolated sphere of radius 12 centimeter. Now we shall discuss about the third part, and radius of sphere is given to us 12 centimeter, means 0.12 meter, and the capacitance is equal to R upon K. The value of R, means radius of isolated sphere, is 0.12 upon value of K, 9 is into 10 raised to the power 9. So 4 by 3 into 10 raised to the power minus 11, or 1.33 into 10 raised to the power minus 11 farad. This is the capacitance of an isolated sphere, that is 1.33 into 10 raised to the power minus 11 farad, and capacitance of the spherical capacitor is 5.5 into 10 raised to the power minus 9 farad, and we know that this value is much smaller than this value. This capacitance is much smaller, means C dash is much smaller than C, and it happens because here is the capacitance is given to us, and determine the capacitance of capacitor, because when we use two separate concentric spheres, then it decreases the potential and increases the capacitance. So here is the capacitance increases, and here is the actual capacitance of sphere is obtained in this manner. So this is the third part of the first numerical, So there are the three parts. There were the three parts. The first part to determine the capacitance, the second is to determine the potential, and the third one is compare it with an isolated sphere. So it was the solution, and now we shall discuss about the second numerical, which is based on cylindrical capacitor. Solution of second numerical. A cylindrical capacitor has two coaxial cylinders of length 15 centimeter. The length of cylinders is given to us 15 centimeter, and radii are 1.5 centimeter and 1.4 centimeter. The outer cylinder is earthed and inner cylinder is given a charge of 3.5 microcoulomb. Determine the capacitance of the system and the potential of the inner cylinder. So this is the numerical, and now we are given the length of the cylindrical capacitor is 15 centimeter. Now we convert it into meter, 0.15 meter, and RB is equal to 1.5 centimeter. And when we convert it into meter, the value will be 0.015 meter, and RA, the radius of inner cylinder, is given to us 1.4 centimeter, and we convert it into 0.014 meter. So 1.4 centimeter is converted into meter, and that is nothing but the 0.014 meter is the value. And now this is the value, and the magnitude of charge Q is given to us 3.5 microcoulomb. We convert it into coulomb, 3.5 into 10 raised to the power minus 6 coulomb. So these are the whole values given to us. No dielectric substance is filled between the space of cylinders which was filled in the previous numerical. Now we shall calculate the two values, the capacitance of the capacitor, cylindrical capacitor, and potential of inner cylinder. So these are the two values given to us, and now the value of capacitance, we know that C is equal to, formula is 4 pi epsilon naught L upon log base E RB upon RA. Into 4 pi epsilon naught L upon 2 into log base E RB upon RA. Now we put the values. The value of L is 0.15 upon 2 into log base E 0.015 upon 0.014. This is the value we have put. Now we convert it base E into base 10. So the value of capacitance C is equal to 0.15 upon 2 into 2.303 log base 10, 0.015 upon 0.015. And the value of C is equal to 0.15 upon 4.606 2 bar. The value of logarithm is 1761 minus 2 bar 1461. These are the values, and value of C is 0.15 upon 4.606 on solving this of logarithm, and after antilog we obtain the values 0.3, and the capacitance of the capacitor is obtained 9 into 10 raised to the power 9, and here also 9 into 10 raised to the power 9 we obtained into 9 into 10 raised to the power 9 are the values of K, which has value K is equal to 1 upon 4 pi epsilon naught. So on solving it, the value is 1.2 into 10 raised to the power minus 10 farad. So on solving, the capacitance or parallel plate capacitor is obtained. C is equal to 1.2 into 10 raised to the power minus 10 farad. Now we shall calculate the potential, and V is equal to, we know that Q by C. The value of Q is 3.5 into 10 raised to the power minus 6 upon 1.2 into 10 raised to the power minus 10, and the value is obtained 2.9 into 10 raised to the power 4. 2.9 into 10 raised to the power 4 volt. So this is the numerical, and we can do this at this place. V is equal to Q by C. The value of Q 3.5 into 10 raised to the power minus 6. The value of C is 1.2 into 10 raised to the power minus 10, and the value will be 2.9, 1 into 10 raised to the power 4 volt. So this is the value of potential, and this is the value of capacitance, and these are the numericals based on the spherical and cylindrical capacitors. And this is the potential, the second part of the question, and this is the first part of the question.